Thank you for being here this early. We're going to be talking about build and testing and so on this morning. Has anyone here got experience with automation? Some of you. What you'll see that there is a change in nature. It's not the same, a little bit faster, as Ford said about vehicles. Cars are not faster horses. It's a change of nature. And if you look back, you will see that there is a considerable change. So this is a very strong change. It's a change of nature, and it changes our way as developers. What we're going to be doing in automation has to do with the processes. This is the easiest case, but there are very many other things. The point here is that all the activities that have to do after development, beyond developing an app, you have to make a build automatically. We need to make it work automatically. We need to test it automatically. We need to test certain things automatically so that we can control whether things are right. And if they are bad, we can very quickly solve them. Our world is becoming more and more complex. We need to do this many times. We have to do it very frequently, many times, because we need different technologies and different machines and different configurations. And at the same time, we have to do it many times because we have changes that are more frequent. What we're going to see is how to automate. Well, I'm going to tell you that these are processes that are going to be far more effective and more efficient, and we're going to be far more reliable. We're going to see why we are doing this. Let me advance this. In Spanish, we say that it's good and nice and cheap. Yes, in English it's good, cheap, and fast. There's a pun here in Spanish that is difficult to translate. You have to try and get the three, but you hardly ever get those three. However, in this case, we're going to try and make the three work. How are we going to do this? All right. This is the cycle I was talking about, DevOps, the development, monitoring the operation of the entire work, and we're going to be using three technologies. One that you know very well, and that's Genexus. The other one, which is MS Build, Microsoft and created Build, and Jenkins, which is an motor to automate processes. Who of you knows MS Build? Good, a few. All right, MS Build is a program, is a language for programming. It would be very difficult to teach those of you who don't know it, to teach you a new programming language. But what we're going to try and do is show you the minimum conceptual things that you must know to be able to understand the rest of the things. And we're going to try and do this quickly. The MS Build, he corrects himself, is a program that is written using the format XML. And you are going to be editing text files. If you use an editor using syntax coloring, it's going to be far easier. This language is declarative. Instead of having a procedural language where you say, I want to execute this, and then this, and then this, the heart of the MS Build language is to declare what the possible objectives to be carried out are. One of the most important concepts is to define targets, that is, targets to be fulfilled, to be reached. And for targets, you can specify, and in the case you want to comply or get to those objectives, what the tasks to be carried out are. And this is an example. We are declaring a target here, OpenKB, in whose case, to get that objective, you have to execute these 3 tasks, and they are a node in XML. This is a task establishing that there is an error, and in case a certain condition takes place, and in this case it's saying working directory, for which I have to open the knowledge base of this KB, and it wasn't established, so it's an error, and I'm saying working directory, not working. Then there's a task putting in a message, and then there is a task saying open that knowledge base. This is an example of a declaration of an XML and the tasks, the objective to be achieved and the tasks to be carried out. All right? Something else that you get in an XML of MS Build is the properties, and they are defined in this way. It's a node of XML with a certain name, and in the center you have the value, the content of the node. So for instance, here we are declaring a server URL. This is the content, and we are declaring a working directory with its value, right? Now, how... I haven't shown you, I'm sorry. This is the declaration of 2 properties. The use of the properties is what we saw in the previous slide. This is the way of making reference to a property, right? Between pesos and brackets, the name of the property, this represents the property. So we carry on. Something else that you do in an MS script, MS Build, MyScript MS Build, is to declare more than one objective. As I said, objectives may have tasks associated to them, and I'm saying for the objective open, we would have to carry out task M and O. For the build objective, it would be to execute J, R, and so on. And the other thing that's declared in script MS Build is these arrows that indicate that, for instance, objective update depends on whether objective open has been carried out in the knowledge base. In this case, to make an update from Genexus server, I have, first of all, to have opened the knowledge base, to do it in the knowledge base. Now, build is saying that it depends on open, and it depends on the update. And so, when you call a script MS Build, you have to state what the objectives are, and on the basis of the objective you're asking for, it depends on other targets, and then the tasks for each task that will be carried out. Let's run a test. Let's make a test and see what happens. This is a call to that script MS Build. I'm calling the engine. I'm saying what the name of the script is, the name of my file, of my script. I'm saying what the target is, in this case, open, and I'm putting in some properties for the property KB pass. For the task environment, use this. Don't worry about properties right now, but suppose that we are saying the target is open, and the first thing we have to see is whether that target open depends on any other target. Does it depend on any other target? No. Therefore, since it doesn't depend on any other target, the only thing we have to do is to execute the task that we have here. So we're going to execute that, E, M, and O. Now, suppose that what we are asking you is target update. So the first thing we have to see is whether the target Update depends on any other target. Depends on which one? Update depends on open. Now, open, does open depend on any other target? It doesn't. Right, so we are going to execute what we need for open, and then we go back. Does it depend on any other target? Does the update depend on any other target? No, so that's it. So we execute open, and then we execute the update. Very well. So we execute those from the open and from the target. Let's see if you can pass the test. And let's see the next case. Suppose you are asked to execute build. And so the first thing that we do is, does the build depend on any other target? Yes, it does. From open. Okay, depends on open. And so you execute things of open because open doesn't depend on anything else. Does build depend on any other target? Yes, on the update. And so it's going to execute the following tasks. Which are they? UXW. Very well. And then it has to execute the build. J and R. Good. Very good. You passed the test. So now you know everything that MS Build needs to be executed. When you call a script, you do exactly that process, right? Now, of course, there are many more things and many more possibilities to use it in the MS Build, much more technology and possibilities. And of course, that's for you to try it out, do research and learn, but it's enough for today. MS Build, this is MS Build 101. And then we are going to be using this to describe automated processes, right? Now, what's the architecture that we're going to use to automate things? This is the architecture that we're going to set up to automate. In the first place, we have some machines using Genexus, as it always happens. Then we have a Genexus server, which we use as a repository for KBs. And we usually use from these machines with Genexus to make commits and updates in relation to that Genexus server. Apart from that, we're going to have another machine, could be the same or not, but let's, I put it separately because it's not necessarily the case that it should be the same machine. There is another machine with Jenkins installed, which is an automation engine. That Jenkins is going to be consulting Genexus server to know whether in a certain KB there was another commit, and to trigger updates, deploy, and so on. By automating all that, it allows you to put applications in functioning somewhere. This is the general architecture, conceptually speaking. Now, what do you need to install a Jenkins? Well, the machine where Jenkins is must be Windows, particularly because it needs Genexus. So Genexus determines, at least for the time being, that it has to have Windows. It must have Java. You can download it from the internet. It's free of charge. It's an open system. It's just downloading it and installing it, and you have instructions there. I'm not going to bore you with the process of downloading it and installing it. Most certainly you can do that with no problem, but I'm going to show you how the initial configuration of all these things would be, so that you can do away with the uncertainty that you may have, whether it's complicated or it's easy, and you'll see it's very easy. So let me sit down a minute and show you what the process is like. Very well. This is the scenario. I've got a Genexus with a KB, which I am usually developing, which is this one here at the top left-hand corner. With this, I can modify targets, objects, and I can modify objects. I make a commit, and I modify what I've got in the Genexus server. So far, because I haven't been using anything that was automated, I had another KB, which is a KB that belongs to no developer. It's the integration KB, where someone would manually update it with Genexus server, and it would make a build, Genexus, and thus it could update the integrated copy of all KBs. Good. Here I've got the application generated in my own development KB. It says Jenkins version 1.4. And then here is the one that is generated on the basis of the integration KB. And at present, they are exactly the same. I'm going to start using Jenkins to automate that process that was done manually. So the first thing is Jenkins. Let me see where it is. I think it's here. And here I've got Jenkins. It's not working. That's the Jenkins I've got. I've just installed it. Well, there are some projects there that have already been created. Don't worry about it. This is a bit slow. Now, let's suppose that you've just installed it. There is nothing specific for Genexus. You've just installed a Jenkins, a standard Jenkins installation. So what we're going to do is to include some Genexus things. It's not working quite well. Let me see if I can do it. Let's see if I can improve. If I can improve it. It takes a while to respond, but well. Okay, so we'll go to Jenkins configuration, manage Jenkins. There we have a way of configuring. Jenkins is a very sensitive engine where you can include plugins done by very many people. We have made plugins for Genexus that have been published in Jenkins. Here is a list of those that have been installed, and here you have a list of those that are available. And among those that are available, I'm going to look for Genexus. It's over there, and it tells me that there is a Genexus plugin that is available. I'm going to mark it. I'm going to say download it, install it, and make a restart of Jenkins. Restart Jenkins once you've completed it. It's installing it. Suggestion was that I should increase the size. All right, is it better now? All right, there you are. It shouldn't take this long. This is live. So there are, of course, potential problems for something that may not work. Right, it's installed. The Genexus plugin has been installed. It's there on the list. Now we've installed it, something else that we can do is to go to our configuration of tools. In Jenkins, there is a section where you can configure different tools, and there are things here that are relating to JDK, Mercurial, MS Build, etc. And in the same way as you get those, you get this one from Genexus. And in my case, they had already been cataloged. So what we can do simply is declare where we have Genexus installations. We can catalog them. We can give them a name. And we can say version 16U3 is installed in a certain path. And we can also say for this Genexus installation, use MS Build catalog also with that name or under that name. So these are possible Genexus installations that I may use. That perhaps for a certain product I would like to use version 16U3, but I may want to use Genexus 16U5 for another project. Here it's U5. And then you could say, well, how can you make a project for these things? And what we're going to do is to have a new item, a new project of integration in Jenkins. We're going to put in a name. Let's suppose that we say, we call it, we name it integration DevOps. We say it's a freestyle, and okay, it's very simple, the simplest of all cases. There may be many other sophistications, more options that you may use, but let's do the minimum necessary now. So this configuration of a project, as you can see, there are several sections there. In one of them, or some of them, we're going to put in information. So the first thing has to do with source code, SCM. So it depends whether it's a Git, a Subversion, a Mercurial, or in our case, Genexus server. When you've got a Genexus server, then you have to say that for this project, we're going to be using Genexus 16, what we've seen that was in the catalog. We're going to be using a URL of a Genexus server, which in my case, for this example, the URL would be the URL of this service, of this server. We'll put it here. Then we have to enter some credentials, and in this case, Jenkins allows you to enter new credentials that have already been cataloged in the combo that we've seen. It's going there and using them. So I'm going to tell them to use these credentials. We have to tell it the name of the KB in the server, which is what we've got here, under properties of team development in Genexus. This is the KB name. This is the name. And we could also say that it should specifically use a certain version. We've got several advanced options. I only have to say MSQ server with which Genexus is working for KBs. In this case, is in my own machine. So that's the part of SCM. That's where that part of the KB, we're going to check if there are any changes, and we're going to include them. Then we have build triggers. When is a build triggered? And what we're going to be using here is ask Genexus server. And the other thing we have to say is how often to consult it, or when. For this, Jenkins has a certain grammar. It's a standard format that is used in many engines. This is quite sophisticated, but out of this long explanation, we're going to take a very simple case. For example, if you want to if you want to check every 15 minutes, then you have to use this. We're going to copy it, here, that same expression is here. And so instead of doing it every 15 minutes, you want to do it every 5 minutes, you change it here. For our example, that's enough. Then we have to say that in case you're going to be checking with SCM and you find that there are changes apart from updating its own working copy, what must it do? What are the build steps that must be taken? And so here we can add build steps here. Among them, we have several options. Some of them are Jenkins standards, others are plugins, and in particular, there is one that makes available the plugin that we installed at the beginning, Genexus plugin, which is a build step that's build Genexus KB. And so we're going to say that what we want to do is to build of Genexus KB. And once again, we say what's the Genexus version that we want. We're going to say where we have the KB, the knowledge base, and in this case, we're going to be using the same one we've been using when we were doing it manually. We're going to tell it to connect with itself, and we're going to say that our knowledge base is here. Version environment. We're not filling it in, and it's going to go to the default, and that's the main version. We're not filling it anything there. And we save it, and that's it. Our project, integration project, is ready. Now we have to test it and see whether it works, and that's the difficult part. So if we go back to our Jenkins dashboard, among all the projects that you can see here, there is one called Integration DevOps. That's the one that we've just created. It hasn't had any activities so far. So we're going to try, we're going to test. It's doing something now. What's it doing? Oh, it didn't find the KB. So probably I wrote something wrong. Let me check, because it should have found the KB. So it, all right, for some reason it didn't find it. So perhaps because, okay, let me see. I didn't put in here. I didn't say that the KB existed. This is what we're going to be correcting. It's in Jenkins webinar. Now, one of the things precisely that is good about automating processes with this type of tool is that it's not that you are eliminating errors. I do this all the time. I've practiced it several times. However, I made a mistake. It's not that you avoid errors, but once you find the error, it's easy to correct them, and that they will never occur again. Once I made this correction, this is not going to happen because it's recorded, so it's saved. Now that I've corrected it, I'm explaining this to you because what's happened is that I hadn't put in correctly the path of a KB that already existed, and then since Jenkins didn't find that the KB existed, it went through another alternative. Now, when the KB doesn't exist, I bring down a copy from Genexus server. In this case, it did exist, so that's how we corrected it. Now, let's test it. Let's make a change and see how Jenkins can take it up. To make that change, for instance, we're going to go to the domains, and in these domains you have one that is called constant applications, and there is one that has the name of the application that we can change. Instead of call it Jenkins webinar, we can call it DevOps. DevOps Love, and we are going to say that instead of 1.4 is 1.5 as a version. We make those changes since we are very methodical and neat. We are going to check that the build is working. We're going to check if the app that we've got locally associated to that KB really has what we want it to be. You can see that the name has changed there. And now we have to make a commit so that the one that is updated is the application resulting from all this. So since we agree with the changes we've made, we're going to go to the team development window. We're going to check what commit is pending, and we see what we've changed in the domains. I don't know if you can see it very well, but those are the changes in the domains. We put in a comment here. Changed app name and version, and we make a commit. So the commit is ready. Now we have to see what Jenkins does with all this. I said that Jenkins checks against the Genexus server every 5 minutes, so there may be some delay until Jenkins realizes. And let's see, here we have the last log. The last time it checked, it was 9:37. So in theory, it should be 9:42. We are at 9:41. At 9:42, it should check, find that there are changes, and show them. If you are too anxious, you can always trigger it manually. What you say? Should we wait? Should we wait a couple of seconds? Let's wait. All right, we'll wait. You relax. I was nervous. Would it work? Wouldn't it? Yeah, you say let's wait because you are sitting on the other side of the desk, but those here, I'm putting in a face. You see, it's saying number 2. It means it's checking. Oh, wow, it worked. So while this is working, it's even possible to see the output of what's happening, which is not what it should have happened. It made a checkout. I don't understand why, but we can see what it's executed. Let's see. Is it creating a new thing here? Let's see if it works. Very well. It showed an error, which is connection to the network. Okay, well, anyway, you're going to see this better in the practical part. I may try to correct it, but perhaps it's going to take too long, and we're not going to be able to finish this. And I think it's far more useful to do this in the practical course afterwards. In the practical course, we're going to be using another KB. All right, I still have one there. All right. As I was saying then, we're going to use the KB in the practical course with the application of this event. The application where you have the web page and you can look at the event page, the speakers, and so on. It's the same KB that appears in your mobiles of GX29. Now that KB takes something like 20 minutes to set it up and, the initial build. So during the practical course, that could be too long. So in the machines, in the computers you have there, that same scheme is already prepared. There is a local KB and an integration KB, and in each one of them, we have synchronized them with a Genexus server. There is a build that's already made, and the functional application is published. So in the practical course, what you're going to do is you're going to do this exercise of creating one of those integration projects as if they didn't exist, so that you can see how to configure it. And then, similarly to what you do in cooking classes where they show us that they are mixing all the preparation and they put it in the oven, and without waiting for them to be cooked, you get the result out of the kitchen drawer. So this is what we're going to be doing. Let me tell you something else, a couple of things. What I said, this is the standard project, which has these steps. It's updated against a certain KB in Genexus server. It makes a build and it makes a deploy somewhere. That somewhere could be the system in production, the main production system our customers are using, or it could be for previous steps before production. It could be a place where we put it so that someone can test it, performance tests, functionality tests before making it available to all customers. And then the other important thing here is that in a Genexus server, you can also have various versions of one same KB. So you may have a main version, which is the next big version to be released, but you may also have a branch that corresponds to the latest version release to have the possibility of making quick repairs, as in the case of Genexus, we upgraded to a certain version. So in a Genexus server, you may be making changes in that same KB, but in different branches of knowledge. And in the same way, when you make integration processes in Jenkins, you can relate them to any of those branches. So what we've seen simply is a standard case, but there are many things to be automated. And let me conclude by saying what we said at the beginning. It seemed that it was too good to be true, that it complied and fulfilled the three things instead of the classical thing when you have to choose 2 out of 3. But particularly, why do we say that it's far more effective and efficient and reliable? The question of effectiveness is that insofar as you can automate it, you are formalizing it, you're documenting it, and it's fixed. It doesn't depend on my making a build or a deployed every time. If it's not manually, we have to depend on the person to remember how it was that he did it, that he doesn't make the same mistakes and so on. From the effectiveness standpoint, is much stronger. That's the example. Those errors that I made and that I can correct, once I've corrected them, they are carved in stone. I know that the next time it's going to be executed, the same steps with the same values will be executed, right? Now, the other thing has to do with efficiency, and perhaps that's the one that we can see it very clearly and more rapidly. Insofar as this is automated, this is done without a person executing it, checking, waiting for this step to finish, and then checking with another one to see whether there are any errors or not, and to continue. So it's executed autonomously. You can execute many at the same time. So efficiency would be impossible to be done manually. In Genexus, for instance, we have many integration processes that are constantly running all day long, and they're constantly checking whether there are any changes in the version and making a new Genexus version available. And the other tools, for those of us in Genexus, others are checking every night to publish a new preview, a new beta. Everything is automated, whether there are any changes in the sources, to set it up, to package it, to create the setups, to transfer them to the data center, the mail that says that everything worked fine or everything went badly, the recording on the internal system that there is a new version with a certain date and number and so on. All that is automated. It's done all the time. This is something that would be impossible to do manually. And the other thing has to do with reliability, and that's precisely the thing of knowing that you're not making mistakes and they're not errors. And when you do it manually, you are always bound to forget something or make a mistake there. But the moment it's there, in the engine. There is no way of going wrong. So what I said at the beginning, you have the best of the three legs: total effectiveness, total efficiency, or total reliability. I'm not sure if it's total, but I would say much higher effectiveness, much higher efficiency, and much higher reliability than when you do it by hand. And what I said earlier, those who try it never go back. Those of us who have been here for a long time, it seems incredible to think, how was it that we did this manually? How did we do that manually? There is a no return path. These are the links to download Jenkins, install instructions. This is going to be recorded for reference. There's also documents about how to configure Genexus plugins. There is a forum. We have a forum of the Genexus community called Build and Deploy, and those of us interested in this type of thing share information, make questions, and so on. And particularly what's coming next, the practical side of it all, when you yourselves are going to try it out, and you're going to really see how meaty all this is, how juicy it all is. And that's it. We can move on to the practical course after this. Any questions? If you've got questions, Cecilia's got the microphone. I'm checking how we're doing with our time. All right. There's a question over there. Hello. My question is with EBOB 3. Is there support for it? Yes. Yes, it also works with Evo 3. It's done in such a way that it can use the components of Evo 3. And that's why you also have that option of being able to choose, what Genexus installation to use and so on. Hello. What's a recommendation that you can make about reorganizations? We've already got Jenkins in 100% of all projects, and many times the process stops at reorganization. So we know we put organizations tables now, but when a developer makes a commit of the generator, you say yes, and then it stops. I don't know what your experience is that you could share with us. I didn't understand what happens when you make a commit. What does it happen? What happens if there is a change in the X server, GX server, and it must reorganize? Many times it happens that Jenkins stops because there is a reorganization screen that comes up. But doesn't it work with the organizer table? We say no in the KB, but locally it changes to yes, and so the developer changes to yes, and it makes a commit. All right, yes, I've understood. Well, what our colleague is saying is this. They have marked in their KB that it shouldn't reorganize the tables in such a way that Jenkins, if you make a build in Genexus with IDE requiring reorganization, Genexus would present the impact analysis and will give you the option to execute it or not. In case it executes through MS Build, which Jenkins authorizes, that is, if you do it through Jenkins, in the case there is another reorganization by default, it doesn't ask anything and it executes it. It could be good in some cases and bad for other cases. In their case, they don't want the reorganization to be executed automatically when they use Jenkins, so they marked in the KB that in that environment, reorganization should not take place. But what happens is that some developers makes a mistake and modifies it because it's using his own KB and makes a commit without realizing that that is being changed, and then the process is locked, it's stopped at Jenkins because of reorganization. Your question was what to do, whether we have any recommendation. Well, the first recommendation is to fire that developer. Fire him. No, well, come on, it's a joke. Well, what we do for those cases is that some properties that are very critical and that we cannot really say that they should depend on someone making a mistake or not making it. What we do in the integration process itself, we put a set explicit that is as part of the build process. There is a set of that property, which is reorganized tables or not. I'm pointing at this screen, but there is nothing on the screen. But what I had shown you, that you were configuring in Jenkins, that it said build Genexus KB, and you would put in some data, and that was enough. Below that, under that, what the plugin is doing is calling an MSB with some targets and necessary properties for the KB. That MS build is in Genexus KB. He corrects himself, in Genexus installation. Now, in the process, in Jenkins process, you could add additional steps, doing things, calling other splits or doing other things, or you could change the MS build being used in Genexus installations to do things when you ask the build for the build. This depends on a target of making sure that this organizer table says no, with a task that says set the task at. That's what we do. And that's useful for cases when you have to put in credentials or values or routes of a certain database or an application service that are different. I mean, those values for the automatic process is different from what each developer does. So as part of that integration process, you make those sets explicitly to make sure that the values are correct and that it works out. And once again, that's one of the advantages. And the advantage is that you have all the values and the steps there. It doesn't depend, they don't depend that Federico, who is the one that does this usually, but tomorrow he can't be because he got married and he went away on his honeymoon. Then we have no way of making that scheme. When it's formalized, we avoid that. All right, I'm sorry it took us too long. Any other questions? Please introduce yourself, because I've never seen that you've asked anything. Okay, my name is Valverde. Jodal also mentioned me. I'm becoming famous. You know, no one knows you. That's why I asked you for your name. I'm ashamed. All right. Is it possible to make decisions in the MS build if you see that you're doing something and this is the wrong path? And could you use an MS build, taking into account different scenarios already programmed, instead of saying, oh, well, you did this wrongly, and da, da, da. Yes, I understand. So that it could determine that, well, if you went this way, I see. Yes. What is usually done, well, we've got two components here. On the one hand, you have the automation. No, he corrects himself. Yes, the automation of the process. I mean, what are the steps to be executed, in what order, what values, what properties, what conditions, blah, blah, blah. That's the process. And then you have Jenkins, and Jenkins automates the triggering of the process and the traceability of results. But the process, the automation, is based mainly on script MS build. One or two calls to MS build or to certain tools using, I mean, that's an entire process that you would put in Jenkins, and you would say what the process that you want to execute are. Now, what you usually do is processes are also part of development. You write in my script MS build, you execute it manually, you see how it works, login and so on, and you start modifying it, you purify it, you develop it until it's ready to say, well, this is my automation process. And then you put it up in Jenkins, and usually what you have to do is that there are some small errors that you would go and change some configurations there. But the process, the strong process of getting to that ideal script where everything is included, well, you needn't have to do it triggering from Jenkins. You can trigger it manually, iterate it as many times as you want, and that's it. Now, if I want to make decisions, my question is, I realize that in the process I've made, there is not a scenario, one single scenario. There may be two scenarios. So if if it didn't work, if it failed, run B, and if it failed, run C. To program it as a batch processor, where you say, well, error equal 20. Well, yes, you can do that with MS Build. Language is a bit different. It's declarative, but you can do exactly the same. You can define that in such conditions it's executed or not, that such task is executed if there are certain tasks, there are certain targets, and yes, you can program all that in MS Build, or in a combination of MS Build, or perhaps you've got a .bat outside that would call the MS Build several times. You can combine it as you like it. But the expressiveness of the language is full. All right, very well. We've run out of time in this block for questions now, so we are going to go into the practical side. It's in the Picasso room opposite this one. Thank you all.